looking to develop a career in mathematics, or maybe you're not sure whether you should take mathematics as your career or should do something else. Are you aware about the current market trend? What are the areas of research which are emerging? Do you want to travel outside India and study your master's or maybe do advanced research in mathematics? Do you know what are the areas which you're already strong in and what are the areas which you need to work in? What are the new emerging career in mathematics where there is less competition and you can do great? Well, if you want those things, this video will give you the answer. So sit back and enjoy this video because I'm going to give you a complete roadmap, a complete path, a complete guidance in which you can develop a career in mathematics. I'm going to answer what are the most confusing questions and the question you should ask yourself before you plunge into developing a mathematical career. So sit back and enjoy and don't skip this video because each of these parts are related to each other. Each of these parts would answer to one of the questions which might be going on right in your mind. So sit back and enjoy your journey. You see, what I tried to mention in this part is that there might be a love for a subject. It can be, let us take mathematics right now, but it can be physics, geography, statistics, anything. So you have got already a love for a subject, right? On the other hand, you also are looking for a job. Now you have to decide between these two because so you have seen on the screen that I have put the heart sign at one and the money at the other part. So it might happen to you that you really love this subject, that is mathematics. You want to develop a career into mathematics which is into research or anything like that. But the current scenario or the current situation is not permitting you to do. Maybe you have got financial problems, maybe you have got social commitments, maybe you have got family commitments. So you might think that, okay, I love this subject, but what to do? Let me go into teaching, maybe as a professor, into banks, financial institutions, because as a mathematician, or if you have got a strong knowledge of mathematics, the career options are huge. It is quite a big one. So the basic point what I'm trying to make is that if you love a subject, that is fine. But you have got financial and other problems in which you cannot pursue the subject at a much deeper sense, that is also fine. So either at one point you take up a job, right? Either as a job as a professor, as an adjunct professor, as a teacher, as a, you can go into corporates, you can go into banks, you can go as an assistant, lab assistant, you can go into anything. There is no problem, there is no harm in that. Maybe you love this subject, but you really don't want to go into job, right? You want to pursue a career which is pure into mathematics. You go into research, you go into developing theorems, extending the theorems, and go into number theory, whatever it is. That is also fine. So the basic point of making this part of the video is that if you really want to pursue a job, taking mathematics as your core knowledge, you have got immense chance. Don't brood, don't lament, or don't feel bad at the end of the day that, oh my goodness, I love the subject so much, but see what I'm doing. I give you a classic example of my brother who is a chemistry gold medalist from the Presidency College, and at the end of the day, his 20 long years has been into banking sector. Now, he also always used to tell me that, Shauna, what I'm doing, I have got a gold medal in chemistry. I should have got for a further PhD or further into the study, but I'm doing a job. So you see, he has got his financial problems. Maybe he thought that a job would have been better. So he is doing that. And he is doing much better than others. Maybe he has got a kind of an analytical brain. So mathematics gives you a kind of an analysis, an analytical brain in which you can do things in a better way. So the basic point of this part of the video is that if you go into a job which is mathematical oriented jobs, that is fine. If you don't go into a job and pursue a career which is solely into mathematical research, that is also fine. Both of them are equally respectable, both of them are equally good, and both of them gives you a go ahead in the career. So don't think that a mathematical career only means research. Mathematical career can also be something into job and related to earning money. So you get a good salary, you are well settled, you're respected throughout the society, and you have got a career which has got details in mathematics, fine. Else you go into research, but both of them are good. So you have to decide which one you want. You have to be absolutely clear in your mind. I've seen many people who have got a great liking for this subject. At the end of their life or after some time, they feel, oh no, I cannot pursue this anymore. So let me get into something which really gives me a livelihood, which earns money where I can run my family. So think in either way. If you're going for a job, that is also fine. If you're going for research, that is also fine. Considering the current social economic scenario, you have to take up your choice. This thing, I know that you already know what is a pure and an applied mathematics, but my point is different. You already know that pure mathematics is something where you're doing research or anything that is related within the domain of mathematics. That means you're not going outside the domain of mathematics, you're doing something intrinsically. Maybe a research on prime numbers, for example, Poincare conjecture, for example, Fermat's last theorem. So number theory and Perelman's Ricci flow discoveries all are within the framework of mathematics. That means you're not venturing out to the application part. Applied mathematics, as you already know, engineering, ergonomics, which we just talked about, all those things are related to applied mathematics. That means I'm using the knowledge of mathematics in order to do something which will be beneficial for some kind of a business domain or for human beings. But what I wanted to tell you is that point number one is that you will always see that there is an overlapping factor between pure and applied mathematics. I mean to say, no pure mathematics is pure, and there will be a slight shadow of applied mathematics into pure mathematics. And in applied mathematics, no mathematics is applied until there will be a little bit of shadow in pure mathematics in applied mathematics. So whatever way you do, even if you're doing a research in pure mathematics, you will see that the type of technology, the type of methods that we discover will ultimately come to some use. Right. So this is the difference between pure and applied mathematics. But remember that pure mathematics will always contain certain areas of applied and vice versa. See, when I say that, what do you mean by career in mathematics? Now, mathematics has got a wide range of career, right? So you can go into, say, for example, space. You can go as an aeronautical engineer. Even you can go into NASA. You can study astronomy. You can go into finance. You can go into research. A lot. So what do I mean by a career in mathematics is that a career where you're thinking about mathematics, where you're going ahead with the core competency you have. So right on your screen, I have laid down the basic, more or less a broad idea of what could be your career as a mathematics. So watch on this. The first is physics. So you understand physics has got a very wide range of career in physics. You can be a research associate, you can be into lab assistant, you can be an engineer, whatever you like. The second is geology. Geologists also have a strong mathematical sense, and they go ahead and do a lot of researches and study into, the weather conditions, etc. But you need to work in extreme conditions. I've got geologists who are working at minus 27-degree temperature in various places. So that is one career option. Data science, I will pick it up later because data science is one of the most emerging, hot and happening, and a very lucrative career in mathematics. Material science deals with mostly related to chemistry, solid materials, polymers, semiconductors. These things will teach you. Cryptography, yes, a great career in mathematics. I will explain in video what are the options that you have. Mathematical finance is, yes, not related to entirely finance, but you have to have a very good and a strong knowledge of mathematics, and you can actually predict the financial market. You make trend analysis, you make risks analysis, so a lot of things are there. And ergonomics, it is something which is related to, I would say, use of engineering and scientific concepts to create a work environment that is friendly for the employee to work upon. So you includes concept. So I can tell ergonomics, for example, right now I am sitting here, so whether I am sitting in a right position, whether my chair is accordingly, the distance from the laptop or the scene, the humidity, the temperature, the way of sitting, the posture, whether I've got a pain, whether my head position is something right or not. So ergonomics deals a lot with mathematics, but particularly mathematics which will be used for generating an employee-friendly work environment. So starting from transportation, logistics, sitting position, environment, AC, all those things are included in ergonomics. Engineering, I don't need to tell anymore. Engineering is a wide area which you can do, and statistics. It is huge. Most of the market researches, most of the things that you do in order to calculate the chances, probability, statistics are there. So I mean to say, you see now all those things, whatever it is there, you understand all of these are application based. That means you are doing this mathematics, or you're developing a career in mathematics in order to do good for the human beings, in order to improve the communication, in order to improve the sitting position, in order to increase whatever it is. So if you watch my earlier video in Einstein and Tagoe conversation, I have made it a point that yes, any technology or anything, any knowledge is only fruitful when it is coming to research, when it's coming to useful to human mind, or when it is giving some kind of a benefit to human beings, whether it is sitting, standing, eating, going around, etc. But it should come to useful for mathematics, for human beings. So that is all in all what I call more or less an idea of what do I mean by the career in mathematics. So you can just look into that. This is a basic points of career. I would like to show you, just have a look at your screen. Now these are the options which are more into developing a mathematical career. So you see I have mentioned data research analyst, computer and artificial intelligence, hedge analysis, actuary, and data scientist. Now, hedge analysis, I'm not going to explain right in this video because it is too much of a financial kind of it. You do risk assessment, etc. But data research and analyst, I will explain you in details. Computer and AI is also there. Now, what I would like to explain you here is what is an actuarial science, or who is an actuarist. Now see, actuarial science is something which is very new to Indian context, and the competition is very low. When the competition is low, and if you can survive in this competition, you have got a higher kind of a prospect. So where the competition is high, for example, in areas of research where people are already fighting into, there's no point in going until you are a Kurt Gödel or a Stephen Hawking. So actuarial science is something where we collect the data. So for example, we gather data from somewhere and then we try to predict the future. We try to predict the future of a financial company. We try to predict the future particularly of insurance. So we tell you that, okay, if we collect those data, and then we can tell you, okay, you should give loan to that, you will go bankrupt, so don't go ahead with that. You should involve into this risk or not. You should take a step ahead in investment or not. So it is basically forecasting the future, collecting those data, and there is a huge amount of mathematics involved in it. So you need to be very good in mathematics, in statistics, in good communication, and you should have a logical reasoning. Why good communication? Because general people don't understand those jargons which you use in mathematical or financial terms. So you need to write out in a lucid way so that people can understand. So that is why I call it as a good communication. So it is a kind of a forecasting data. Now here it is something on your screen. You need to pass out what is called ACET, Actuarial Common Entrance Test. 50% is the cutoff mark which you pass, and then you should take up 15 papers in order to pass the examination. Now let me see if I have missed on something. No. So here I have taken a note that they help businesses and clients develop policies and minimize the cost of that risk. So you need to have an absolute great knowledge on mathematics, especially in statistics. And I can tell you one thing, This is an important point. You should remember that when you are going into any kind of a career development path, whether it is mathematics, physics, science, geology, anything, you should remember that you should go into something which cannot be replaced. Now, artificial intelligence and robots coming up, you can be immediately replaced with a robo, right? And then you will say, okay, bye, Shaunak, we don't need you. But actuarial science is something which cannot be replaced so easily. Why? Because you are predicting the future. You are predicting that, for example, I will tell you that what is going to happen in the next maybe 1 year or maybe 6 months, given the data distribution. So this is another important aspect, that when you choose a career path, choose a career where you cannot be replaced. It is irreplaceable by automation or intelligence. So actuarial science, because it actually I would say it depends upon human intuition or forecasting, it cannot be replaced. Capturing, processing, analyzing, manufacturing, and communicating. Okay, these are the important key points of what is actually a data science. Now, see, data science is something which is related to some kind of a messy, organized or unorganized data. So we collect those data and then we capture it, we maintain it, we process it, and then we analyze and we get up certain results. So we try to find out the trends, we extract the data, and then we interpret it. So you can see what I'm trying to tell you, that this is a data, not only data collection, it is data mining, maintaining data, extracting the information, analyzing, and then letting you know, okay, fine, so this is going to happen. Again, a kind of a forecast. So mathematics and statistics, especially the logical probabilities, this is one of the most important aspect of data science. Here in your screen, I have given you a figure, a kind of a Venn diagram. No, it's not a Venn diagram. Anyway, so here you see the data science falls in between mathematics, computer programming, and business. We need mathematics to analyze it, computer programming to process it, and the business idea in our mind in order to give it back to those. So another picture I would like to show you. So when we talk of data analysis, we mean this. So you see there is a cohort analysis, which is a visual display to the analysis to compare different groups. Regression analysis, which variable has an impact on what. Factor analysis, we take the data, reduce it to smaller data so that it is manageable. Cluster analysis, it is a group of set of objects so that the same group are more or less similar to each other and gives us an idea of what and the way we analyze. And neural network. Let me show you a picture. This picture actually shows you what is actually a neural network. Right, so you can understand there is a huge amount of mathematics involved in what we call data science. I would also like to tell you now what are the career opportunities. Here on your screen, this is an overall guide. I have mentioned a lot of positions, but these are more or less the options which you can get as a data scientist. So you see that data analyst, database admin, and this list is quite long. Coming to the eligibility criteria, what you should have in order to become a data scientist. First of all, you need to have a master's. You should have mathematics as your major. You can also have physics or chemistry, but mathematics as a major, master's, or you can have even a PhD. A good knowledge of statistics will be required. And here on your screen, I have shown you what are the mathematics which is required, right? So in this picture, you can look, the list is quite long and includes a lot of complex mathematics. And at the below, if you see, these are the three factors which you should harp on. A very good solid foundation of calculus, a great idea about linear algebra, and you should know probability. Because probability is something, if you see, it will come all the way whenever you are applying certain things in order to know the trend, risk, etc. So you cannot skip probability. So this is what, so I will repeat: engineering, MTech, mathematics as a major, statistics or MSc or anything. Along with that, you need to have those skills which I have already shown you, and obviously you need to be a very good communicator because you will be working with a team of other data scientists. So communication, compatibility, team management, these things will be required. So that gives more or less the eligibility criteria and the mathematics which will be required. Understand that data science is something which is very, I would say, a very demanding, highly paid job, but you have to have a very good understanding of mathematics. Have you really wondered that when you punch your what you call ATM card in the ATM machine out there, how secured your data is? When we go to online shopping, we punch our bank details onto online. When we do bank transfer, NEFT, securing the payment, all those things. This is what is called cryptography. Now, cryptography is basically, I would say, an interdisciplinary kind of area where a lot of things are taken care and it ensures data. So as you understand, I being an individual, I always want my bank account and everything to be secured. The shopping malls or the shopping centers, they want their data to be secured. You want your data to be secure. Every one of us wants a data security. So here on your screen, these are the possible openings which you have as a cryptographer. So you see security engineer, cyber security, crypto analyst, as everyone wants to protect their data, right? Now, here on your screen, you see this picture shows the mathematics involved, and you can see that it is quite an advanced mathematics. So if you are willing to develop a career in cryptography, you have to get a very good understanding of what is shown right on your screen, linear algebra, ring theory, and everything. And apart from that, number one, number theory. Now, what I would like to tell you, say for example, I am coming to your house, I am Mr. A and you're Mr. B. So you have given me a key so that I can just unlock your door and step inside and have my cookies. So I get a key, right? I open the door and I, step into your house. So this is what is called a symmetric kind of a cryptography, right? What happens next is that you give me that key, I come to your house, and there is a door. I open the door and I find another key. So that was was called a public key. I'm not going into the technical details. And then I find another key and unlock the door and I open up and step inside your house to have a cup of coffee and cookies. So that is called a private key. So there are different, versions of cryptography, which is called symmetric and then asymmetric. And there are areas called confidentiality, non-repudiation, integrity, authenticity. So what actually cryptography does is that they make your data secured. And how will they make your data secured? That is through mathematics. That is through number theory. That is through combination. That is through linear algebra. So cryptography, if you go back and read a little bit, you will see there is nothing new. Way back during the Second World War also there was cryptography when the Allied force used to send some data and the Germans used to get hold of those data, and either way. So cryptography is nothing new. It has been happening, right? If you read Simon Singh's book, I forgot. I just forgot the name. So it's a good book on cryptography. You can search it with his name, Simon Singh, and it's a wonderful book on the history of cryptography. So cryptography is going on. And what I would like to tell you, with this current era, when pandemic has hit us and everything is going online, people want more security. So people are venturing into securing their data, corporates, business houses, researchers. They all want, make their data absolutely confidential. So cryptography, I know it is a new concept in India, in US and other countries where my friends are. It is quite common. But as I told you, that you need to have a concept where you can really thrive that. The competition is less. So just to tell you more, that cryptography would deal with mathematics. You have to have absolute great understanding on number theory, and that is the key to success of cryptography. I've already shown you what are the different type of career opportunities which are available. It is good. You can go ahead with that. Financial mathematics. Let me show you what is on the screen. Right there on your screen, you can see that what actually financial mathematics deals with. So you can become an actuarial analyst, you can become a chartered accountant, risk analysis, everything. My basic idea of showing you financial mathematics is that finance, which was 20 years back, is not the finance which is right now in 2022, or maybe the 10 years to come. So there are a lot of mathematics which is being developed in the process of, thanks to the pure researchers, a lot of areas have been developed in pure mathematics, and which is making finance even more challenging, which is securing finance, which is helping the business houses to forecast, to invest, foreign investment lot. Now I know you being a person from mathematics, you won't be interested in finance, nor do I, but I just wanted to show you that this is also an option, this is also an area. And I have seen in my college days that chartered accountants, I don't want to say college did, but in my young days, chartered accountants who are coming from a commerce background, rather the chartered accountant is coming from a mathematical background, they are doing better. A chartered financial analyst coming from a strong mathematical background is doing much better than those people who are for commerce. So as I told you, that mathematics give you that kind of a brain where you can do analysis much better. So mathematical finance is definitely a go ahead. If you're a little bit interested in finance, if you're a little bit aware about the business happenings around, you can take up this career. If you are good at statistics, if you really like chances, if you really like probability, this is absolutely the right career for you. Here on your screen, you see you can be an economist, you can make policies, there is an actuary market, there is also market researcher. So statistics is another thing which deals with probabilities, chances, and as you know, the business market is always volatile. The business market is always ups and downs. You really don't know what is happening. So if you are really good in statistics, you can take up statistics as your career. It is going to bloom. You are going to prosper. You're going to get a very handsome salary if you're really aware about statistics. So statistics, one part can be into pure research, where you're not dealing with business hubs or financials and corporate houses, or you can use the statistics. It is more of an applied kind of a thing where you can use that in the market to forecast and make life look more beautiful. Computation. Now you see, in this part of the computation, I just don't want to tell you about computer programming. Let me give you an example. When we are solving big mathematical equations, so right on your screen you see there is something which I have written as MATLAB, logic, discrete mathematics, and so on. So what I'm trying to tell you is that big calculation, for example, finding out a solution of Einstein's field equations, or for example, modeling, simulation, algorithm development, these are carried on with a software which we all know as MATLAB. Okay, so what I'm trying to tell you is that computation with a good strong background of mathematics is wonderful. That means given a kind of a problem, say for example, you're given a problem to solve a particular kind of a, I would say, set of equations, set of complex partial differential equations, and develop a program into MATLAB. So how do you do? Now there are two people who would be doing that. You being a mathematician, you will be assisting that person who is into computer or AI programming, right? So go ahead and do that. How? So these are the steps 1, 2, 3, 4, etc. It can be finding out a solution for black holes or enormous big astronomical figures. Now that person would be doing out for the I would say what the computation from the logic part, computer reasoning, artificial intelligence, etc. But what you would be doing, those figures, maybe calculation of black holes, Schwarzschild radius, or huge amount of astronomical data which you already know how to calculate. So you do that. So computation doesn't mean that you just go ahead and do programming. No, I'm sorry if I have not been able to communicate in the right way. Computation means that you would be doing discrete mathematics, you do understand partial differentials and many other things, and you, along with the help of that person who is an expert in computer, will be developing an algorithm, a system, a frame of equations which will help people to easily solve out problems. So algorithm development, and if you already know computer, excellent. So you get a double or maybe a triple salary because you're doing two people's job. So if you do have AI, or if you don't have, if you have got a strong knowledge in any kind of a mathematical, I would say, subject which you're strong at, go for these kind of developments, MATLAB developments, theorem developments. That means you're extending a theory, right? If you remember, Bernhard-Riemann extended on Gauss's theorem. Maybe Gauss developed on some other theorem. So theorem extension, when you do, it requires huge computation. Who will do that? It's not possible to do it in hand. They develop an algorithm. So that is what computation is, another career option if you are right on the way of doing mathematics. Meteorology. Now, really, have you ever wondered that your strong skill in mathematics can save a village from a tornado? Your strong skill in mathematics can save a country from an earthquake. A strong mathematical sense can take you into what is called meteorology. Now, you see, the importance is immense. As I told you, you can be a meteorologist provided you have a good amount of grasp in mathematics and physics. Okay, so first let us look into this picture. It shows what is the mathematics involved in it. Okay, first let me tell you what is the eligibility criteria. So first let us look into the eligibility criteria. So this is the eligibility criteria, and writing skill is very important. So this is a note of attention. So those who are very good in writing English, because again, meteorologists use lot of technical skills, lot of technical words which are into physics, chemistry, weather science, and in mathematics. So you need to write in a very lucid way in order to get a good career in mathematics. So coming to the next part, which I was telling, that this actually shows the mathematics involved in meteorology. So you see vector calculus, fluid dynamics, calculus, geometry, algebra, and so on. Now you see what happens is that when there is a wind flow, there is a hurricane coming on. So you really try to predict all those things using this part of the mathematics, which is vector calculus. You have to have a very good understanding about fluid dynamics, otherwise you won't be able to work out. So you see that what is happening, that if you become a meteorologist and if you go into meteorology, you are already using your English communication, I mean to say the writing communication, and the advanced mathematics that you have, because fluid dynamics, vector algebra, calculus is an absolute, because you're taking so many weather, wind, humidity, all those factors. So you have to have a great understanding on partial differential equations, right? Geometry will be required, algebra, and quite a lot. So meteorologists do need mathematics, and if you do have, please go ahead. It is a wonderful career. It is going to save lives, and you are going to enjoy. Quick look in this picture. This picture gives you the job descriptions, or I would say more or less what are the jobs which are available in meteorology. You can be a consultant. You can be a hydrologist, those who are dealing with water. You can be also a natural catastrophe research associate. That means those areas which are prone to natural catastrophe, be it a hurricane or a tornado, you can work. But understand one thing, what I have seen is that for a meteorologist career, you have to work under pressure, and you have to work under conditions which are not favorable. Maybe a storm is coming, or maybe a hurricane it is coming. All those areas, when people are under threat, you have to be cool and calm-headed. So you have to use your mathematical and all those skills in order to predict. And wow, it's great, if you can save somebody, you can save a life, you can save villages and people from catastrophic destructions. I think mathematics serves the best. Very important topic. How will you understand you are good in mathematics before venturing for a career in mathematics? Now see, what happens is that, let me be very honest and frank with you. In my college and my university days, I have seen a lot of people, a lot of students who are, sorry, absolutely great in mathematics, absolutely great, but they fail after their masters or they don't want to pursue PhD. Again, as I told you, love for the subject is one part, and coming back and doing a job is something different. Both of them are good, but different perspective. So be clean in your mind. Now, there is no hard and fast rule where I can tell you, listen, these are the steps. If you follow 1, 2, 3, 4, 5, that means you score A plus, that means you're good in mathematics. No, it is very difficult. But before you venture forward, because mathematical career means that I would assume you won't come back. You would continue either through research or through applied science, applied mathematics. So let me tell you, these are the four important, I would say 1, 2, 3, 4, 1, 2, 3, 4, 5. Five important points here on your screen. Look into that. I will try to explain you one by one. Abstract concepts. This is something you have to be absolutely sure. Concepts like, I would say, limits or maybe calculus, advanced subjects like ergodic theory, ring theory, commutativity, all these are very abstract concepts. You cannot make it through a pen and a paper, and it is not something which is very concrete. So, do you understand abstract concepts? Now, there are certain parameters which I understand. What do you mean by understanding? But as of now, do you really have a grasp of what is an abstract concept? Number two, problem solving skills. You should have a, what I would say, a natural tendency to solve problems. Okay, nobody should push you, or you should not feel, oh my goodness, I'm so tired, I have been doing this, I'm doing this. No, you should have a natural love. I would say natural love, a natural knack, and instinctive liking towards problem solving. Given any problem, geometric, algebraic, number, you are always willing to do that. I used to have that, until I solve the problem day and night, I'm thinking. But again, as I told you, these people are very good up till the master standard. Then when they go into PhD or thesis paper, they fail. So try to be very clear in your mind what I'm trying to tell. Are you that good? I know there is no, I would say, there is no mark which I can tell up to this or up to that, but this is important. Third, love for numbers. You have to be great. I would say you always love numbers, right? Given a Rubik cube or anything, you would like to solve them, and you're really working on numbers which are complex, numbers which are given in front of you, and really do that. You love them, you work with them, you just enjoy, just like enjoying over a cup of coffee or a pizza or something. So you really love numbers. Identification of patterns. Here I am just showing in your screen, this is what we call identification of patterns. So there are different type of patterns which are given: color, shapes, numbers, arithmetic, geometric progression, and you need to identify them. So there would be a natural tendency that you really know how to identify numbers. Coming at the last, which is called geometric and spatial awareness. Here I would like to show you what it is. So I mean to say, whenever there is I'm thinking, say, about relativity, general relativity. So if this is the coordinate system, if it is rotated or if it's stretched, if it is elongated, if it is, bent in this way, I don't have to pick up a pen and a paper and I have to do those things. No, mentally I can do those things. So mental rotations, visualizing objectives from different perspectives. So which is behind, which is on the other side, coordinating how different space, mapping, understanding how items are arranged in space in relation to one another. This should be absolutely clear in your mind. Clear in the sense, I'm saying that you don't need a pen and a paper to do that. You can do it in your mind. I remember one of the talks at CERN, Professor Hawking told that I do most of the mathematics in my brain. Obviously, because of his disability, he cannot pick up a pen and paper. We are blessed, so we should be happy. But overall, the geometric and spatial awareness, so given a kind of an Euclidean, I would say, Euclidean space, okay, then it is immersed in a four-dimensional space, or it is stretched, it is rotated, what lies on the other side. For example, if a cube, if I'm making a stress tensor, what lies on the other side? What are the coordinates on the other side which is happening? This type of a visual mental understanding of geometric and spatial awareness is important. So these are the abstract concepts. You should be clear about calculus, limits, and a lot of abstract concepts are there. Problem solving skills, you should have a love for numbers, you should identify patterns, and geometric and spatial awareness. So I am not saying that this is the final one, but more or less I can say these are the checkpoints 1, 2, 3, 4, 5, and so on, that you can really know, okay, if I understand those things really well, then I can take up or venture forward for a career in mathematics. Well, this has been a debated topic. I would like to tell you mathematics, whether it is a language or not. Now, I don't want to go into any debate, but I feel that mathematics indeed is a language. The point of making this part in this video is that you are going to go ahead with mathematics as your career. So mathematics, you should understand it is a language. Number one, vocabulary, as we understand in English, Bengali, Hindi, or Arabic, which I have learned. These have got vocabulary. So mathematics also have got a vocabulary, that is numbers, operations, variables, and functions. Right? The grammar. What is the grammar? There is a verb and the noun and the preposition. These are operations. And mathematics is the most talked language and can be understood by everybody around the world. Now you might be thinking that why I'm telling about mathematics as a language. You see, I have got similarities. Now, for example, I say something in a different language. Say, for example, Urdu, or maybe I say something in Arabic. Okay, so if I want to express a feeling which is typical to Urdu, say for example शेरो शायरी, or anything in Spanish or French or German, okay, सुना है लोग उसे आंख भर के देखते हैं. So I say a line of Ahmed Farah, सुना है लोग उसे आंख भर के देखते हैं, चलो उसके शहर में 2 दिन ठहर के देखते हैं. Right. So what will you tell it in English? I have heard that people look at her eyes, so let us stay at her city or at her home. Does it make any sense? No. Why? Because we are trying to translate one language into another. And now if I say kaifa haluka, that means how are you as a male? Kaifa haluka. So how are you? You can translate more or less, but that sense, that flavor loses when you translate from Urdu and Arabic to English. Same happens with mathematics. What I'm trying to tell you all is that, you see, I have talked numerous times in my videos that translate these into layman terms. Translate what you call tensor analysis. Translate what is divergence. Translate what is called a stress tensor. Really, can you do it in English? No. Because mathematics is a language, mathematics has its own flavor, liking, and the beauty, which cannot be translated into English. So I just wanted to tell you that let us learn, or let us go forward and love mathematics as a language. So you see, once you start loving or thinking that mathematics is a language, you won't have any problems. Because in the language, what you learn, A, B, C, D, or E in Hindi, right? Here also you learn the terms like notations, plus, minus, algebra, trigonometry, etc. And when you talk, we cannot understand. Why? Yes, if I say in some other language, Spanish, how are you? You won't understand, because that is Spanish. And same happens with mathematics, and that is why people call mathematics to be so difficult. Why we call mathematics so difficult? Because it is communicating a different language, different signs of symbols in it, which you cannot find, which is impossible. That is what I told you. Given Hindi, Urdu, Arabic, Spanish, German, you cannot translate. Yes, what you can do is that you can translate the overall sense. So when I talk of convergence and divergence, I can say that, okay, divergence means something going like this. But that is not true. Divergence has got a lot of internals in it, right? So that cannot be translated. So when you are learning, or for the young students who are learning mathematics and finding it difficult, so challenging, understand that the same thing will happen when you're learning a language. Being an Indian or a German or a Spanish or a French, if you learn another language, it will take same time. It will going to give you that same pain, and over a time you really learn. And as you see, that vocabulary is endless. Can you say that you know all the words in English? No. Can you say you know all the words in German? You know. Don't. Why? Because it is endless. Similarly, in mathematics, mathematics is endless. You cannot say, I am done with mathematics. So the vocabulary is endless. Mathematics vocabulary is also endless. So I think it will give you a good insight and you would fall in love with mathematics. Okay, so here what we do is that we would go ahead in the emerging areas of research. So I would like to divide now into pure and applied. Now, before going ahead and explaining you what are the emerging areas of research, what I would like to tell you that these areas more or less, I have made a thorough analysis study from my professors, students, etc. More or less, these are the areas in which the current researches are going on, and you can go ahead and take right on your screen. These are the emerging areas of research in pure mathematics: algebraic topology, analysis and partial differentials, geometry, ergodic theory, you can go ahead and reach number theory, topology, and differential geometry. So in India, abroad, I have made a complete study and I have understood that more or less most of the reputed universities, institutes, private or public, carries on this research. So you can, if you are going ahead for a pure research kind of a thing, these are the points you should take care. Well, coming back to the applied research, here on your screen, you can see this gives you a kind of an idea. Combinatorics, which relates to probability, and there are a lot of combinatorics which are required. Why combinatorics is required? Because I told you mathematical finance or actuarialist or meteorologists, they use combinatorics, which is related to probability. Computational biology, how will I explain you? Computational biology is something where you use the biology but use a lot of mathematics. I mean to say protein fold. If you remember in differential geometry, I showed you one small research where they're using differential geometry into genetic engineering. If you recall and go back to my video, you will see that they have discovered a 65-dimensional protein structure or something like that. Don't remember, but that's its applied mathematics. So differential geometry, you see it is there. I think, yeah, it should be there. Differential geometry and topology. I think it is there in the pure research. Whatever it happens, so they are using differential geometry there. So you get computational science and numerical analysis. You get theoretical and computer science. You get atmospheric and climate modeling, mathematical medicine and biology, and mathematical finance. So taken all these things together, these are more or less the hot and happening areas of mathematical applied mathematical research. You can take any of these topics. More or less, these are okay, and the universities and the institutes, they offer that. Ergodic theory. This is a very emerging topic in research, obviously in pure mathematics. Let me tell you, ergodic theory is something, for example, there will be, I would say, variation. Okay, there will be distribution of data. Okay, so I've got a set of data, so which is going to change over a period of time. Okay, I've got a set of data. It is going to change over a period of time, but that change is deterministic. Through the time, as the dynamical system evolves, that is deterministic. So let me read out exactly. So it is the statistical properties of deterministic dynamical systems, the study of ergodicity. It assumes that the equations determines the dynamics, not containing any randomness, perturbation, or noise. Now, if you remember Mariam Zaghani, who was the first woman to receive the Fields Medal, expired at the age of 40, her research was into ergodic theory. So you can very well go ahead with ergodic theory. It is not chaos, right? Chaos is something different. So it is a probability. It is a probability which is happening, but in a deterministic dynamical system. So we call this as almost all points in any subset of the phase space revisits itself, right? So this is ergodic theory. Let me quickly show you what are the research points which you can take up in ergodic theory. Here on your screen, it is there: arithmetic dynamics, Bernoulli convolutions, beta transformations, Brownian motion, piecewise, and so on. And the University of California has got a wonderful department in ergodic theory. I know it is a little bit difficult or maybe a new term which is you're hearing, but ergodic theory is emerging. And as I told you, anything emerging you should jump upon because the competition is less and you can do more. So ergodic theory deals with those areas, deterministic dynamical system, which is changing, but the change has got a certain limit. You obviously want to travel outside, right? You are willing to travel outside, do your masters at some universities outside India, or maybe you can pursue your research in mathematics. Now here on your screen, let me give you the countries which I think that it is good for research. Now among this, you see Philippines, Hong Kong, USA, Singapore, Seoul, Germany, India, UK and France. Now, you have taken a note that these are more or less the countries. There are many countries all around. So you cannot tell that mathematics is limited to those countries, but just I'm trying to give you a career guideline. Now, first of all, before going ahead to this country, you know what one thing you should check. Now, you might think that I can go to Germany or UK and study at Princeton or Stanford University. That you can do. Great, great aspirations. But one thing also you have to keep it in mind that any country where you are going, the first parameter is that is it suitable for you? I mean to say the climate, you cannot survive at minus 20-degree temperature. The people whom you're talking, the type of atmosphere that you're in, the campus that you're there, and most importantly, there should not be a kind of a hostile feeling between the professors and the fellow colleagues. Okay, so even if you target a high, great, European countries or somewhere, I'm not naming them, but you might find a country which is just nearby to your country, just to nearby to you, the place where you're living, maybe in Thailand, maybe in France, or maybe in India. That country, although it is not paying you that kind of a high, or you don't have great scholars, but it is suitable for you. My 40 years of experience, I would say, not 40 years, I should say around about 20 years of experience tells that be it studying abroad or carrying up your research, carrying up your mathematics study or whatever, get into a country which is more friendly, which gives you a cordial company, which gives you a complete, humanitarian invitation where you feel good and work with that country. You cannot work with a country or at a place where people are hostile, fighting, and there are a lot of conflicts. Anyway, so going ahead with that, what I would also like to tell you is that I have given a list of few of the countries which I think should be useful. So among these countries, I can tell you USA would be definitely at point number 1. Singapore definitely would be at point number 2 because Singapore's Department of Mathematics, I have interacted, I have students, I have seen that people really, and they have very high standard of education. Great. Not only in terms of mathematics, but in all. Singapore would be 2. So let me show you now. Okay, here on your screen, these are the institutes for mathematical or study. So in India, what I would, for US, I would like to show you that MIT obviously stands for the first, Massachusetts Institute of Technology, Stanford University, Princeton, University of California, and obviously Harvard University. Second, which I consider, because I've got a lot of relatives staying out there and more or less okay with this kind of a country, is Germany. You see on the screen University of Bonn, Technical University of Berlin, and Munich, and Göttingen, and Zuberlin. Now, one thing you should also be clear that there are public and private universities, both in India and abroad. Now, University of Bonn and University of Berlin, they are, all of them are, public universities, but they provide free, they are free. Free in the sense only the tuition fee is free. I repeat, the tuition fee is free, not all. There are a lot of other costs, administrative and likewise. So I would personally prefer Germany, where you can carry on your research or maybe, if not research, your mathematics, the masters in mathematics, right? Now, among these institutes, I have got into, I know that Berlin and Göttingen, these two are more or less of a USA type, American type university. So the people and the culture and those who you mix, they are of more or less of an American type, which you will enjoy. And the medium of learning is also English. So German and English, I will come to the next slide, whether you need to know foreign language or not. So this is called the Hausdorff Center of Mathematics, and they provide quite a lot. MSc at Bonn would be very good. uh, Algebra, number theory, analysis, differential equation, discrete mathematics, geometry, topology, probability, all of them are provided. You can find out your details at Bonn, and at Bonn they have got English as well as German, so you can very well take up MSc in English from University of Bonn. University of Göttingen also, they have got US MSc in English, and Berlin. But Göttingen, yes, because Göttingen is the father of all the great people who have gone out, who not, starting from Gauss. So Göttingen has got a more of a closed culture. Right, the culture as itself in Göttingen is a little bit closed, but that of Berlin and especially at University of Bonn, they are great. You can just go around, mix around people, talk, right? So learning is not just great professors teaching; it is all mixing around, talking, peer learning, etc. So that completes our part of going abroad and study. Remember, go to a country where you find everything to be favorable. I mean to say, where your mind is accepted, where you feel at home. Don't run around for just that you need to go to a country because they are great. And I just read that there is something called, what is called PISA. Yeah, that is a kind of a ranking. China comes right at the top. Best mathematicians at the age of 15, China comes right at the top, then comes Hong Kong, Singapore, and so on. The thing is that, really, does it matter that you go to a country who has got the greatest field medalist? So you go to a country where you have got 10 field medalists, all Nobel laureates, but you find, no, I'm not okay. I'm not finding it good. The temperature, the food, the weather. So I can tell you, go to I would say, tier B or tier C country, but you will do well because your heart and mind is there. So that completes, these are more or less the kind of a brief idea of what are the countries that you should go. So for my side, India, Bonn, and yeah, so here, okay, so we have to show you I have to show you the next one. The mathematical study in India, yeah, number one, TIFR, then comes Indian Statistical Institute, then the Chennai Mathematical Institute, IIT Kanpur, Harishchandra Research Institute, and you can all should try out National University of Singapore, excellent faculty and excellent work environment. University of Philippines, Diliman, University of Hong Kong, Seoul National University in Korea, and Institute of Polytechnique de France, Paris. This is basically for in France. So TIFR, remember, I have got my professors all out in TIFR. TIFR is good, but it is good only in research. I repeat, if you have got a solid research topic which you want to go ahead and do the research, it has got excellent facilities. So Tata Institute of Fundamental Research would be typically for doing research only. ISI, obviously, you can go to IIT Kanpur, where from my father is. They have got all this research, algebra, number theory, analysis, differential geometry, topology, all researchers are there and masters are there in Kanpur. Institute of Polytechnique de Paris, this is at France, and they also have what I would call medium in English. So that gives you a complete idea of what are the countries and what are the things that you should take. Very important question. So do you really need to learn the native language? So you go to Germany, you learn German, you go to France, you learn French. Do you really need it? Well, my answer to this question is that learning is always not within the class. Learning is not always with the professors. Learning is not always through books. Learning is most important through peers, through friends, sitting on a cafeteria, sitting on the stairs, sitting on the open meadow, resting back at home, talking over telephone to maybe your peers, etc. So if that is so, then yes, you need to learn the native language. And not only you need to learn it, because as I told you, University of Bonn or Berlin or even École de France, they all have English as a medium. But it is good to mix with people. Now, if you talk with me in my native tongue, I will always feel a comfort. And if you tell there is a biasness, yes, no doubt there is a biasness. No doubt people are biased towards their own language, and we have to accept that fact. So, if you really want to take ahead and go ahead in doing well, where learning is not within the curriculum, within the stipulated time duration, you should learn the language. I learned two languages. I'm really feel now, because of lack of time, I should learn German, I should learn French, and I should learn Spanish, if not Italian. So if you go ahead, the learning won't be hampered because these are international places. They won't, what I would say, discriminate in terms of gender. But you need to learn because of yourself. You need to learn so that you can communicate better with your fellow members. And learning is much higher, much better outside the class when you're mixing, intermixing, and talking with colleagues. So, yes, I would say go ahead, and learning a language gives you another opening of mind apart from mathematics. Go ahead and learn a language. Have you ever wondered this? Okay, mathematics have been doing wonderful things throughout our career and throughout history. Now, here is one person I would just like to show you. Now, this person, Professor Paulin's fascination with the Cape Cod Bay current goes back to his days when he was a graduate student at MIT. Now, he was doing a research at the nearby Woods Hole Oceanographic Institution, and he became intrigued by the local current, which is influenced by such factors such as the tides, and the topography on the ocean floor. He writes, when the flow is fast enough, the current becomes unstable and produces vortices. That is where the whales enter into the picture. So when a vortex separates, it takes with it colonies of plankton important of the feeding cycle of the whale. Hunting whales need to find a large colonies of plankton to survive. Now, this is very, I would say this University of Waterloo published this long back, but I really felt fascinated. So you see that not only you can do your career better, not only you can do well-beings to human being, not only you can get your own salary and get a wonderful life, but you can save animals, and you can find out, although this is something which is related to hunting, but here in the last paragraph, it can save whales. It can save a lot of animals which are really suffering. So this is a great magic of mathematics, which I just thought to share with you. The last one, but very important. Why should I study or complete a career in pure mathematics? Now, in my earlier video, around about a year back, I just made a kind of a natural video talking on the importance of mathematics and motivating young people to carry on mathematics as a career. Now, when you think of making a career in pure mathematics, what happens? You don't find things around which are tangible, which you can see, which you can really make use of those things, and which is, more or less very abstract. So after carrying on pure mathematics for about 1 year, 2 years or so, you feel, oh my goodness, what am I doing? There is no use because I cannot see anything which is materializing in front of me, anything which is coming to use. But my dear, I would like to tell you that a research in pure mathematics is something which a lot of people have done. There are two benefits. First of all, the time duration that you take. So you start from here and you reach up to here. Okay, the time duration that you take in order to run through proving a theorem. For example, Poincaré's theorem, right? For example, Fermat's theorem. So what did Professor Andrew Wiles got? If you talk, apart from the medals and awards, he developed something, modular forms, a lot of other things which I even don't know, which are either they are used right now or later they will be used to some benefit, to some better lifestyle, to some kind of a beneficial, either to space exploration or to benefit human mind, or maybe to save the whales. Now you see what we thought when we reached up to the moon. What did we achieved? What did we achieve? Technology. Most importantly, with the technology coming across, we invented a lot of space exploration, Mars rover reaching up to Mars, Mangalyaan even failing to reach Mars. Mangalyaan failed to reach Mars, but we from ISRO learned a lot of things. So point number one, when you do research in pure mathematics, get up to a certain level, and even if you fail, don't worry, because nobody climbed the Everest at the one go. People failed slowly, but each failure is a success. No, I'm not giving you any technological gyan or not telling you something, but pure mathematical research always give you the root or brings up the technological or the mathematical or the algorithmic knowledge which will be used in future. Number one. Number two, why not do a research in pure mathematics? Now think what Isaac Newton would have thought. Why would I at all worry that the apple is falling from the tree? How does it matter as long as the apple is tasting good? Why would Galileo observe the rotation, celestial rotations? Why would Nicholas Copernicus observe the celestial rotations? Why would Einstein at his office at Bern would have thought, okay, I am relaxing, and suddenly the floor opens up and I'm falling free? Why? Now, if they would have thought, we wouldn't have got gravity, we wouldn't have got the air condition running, we wouldn't have got even this mobile communication, we wouldn't have learned relativity, we wouldn't have learned optics, we wouldn't have learned spectrometry and a lot. Right. So let us not think that what are we going to achieve. The achievement is step by step. The achievement is your success. The achievement is even your failure. So these great people like Galileo, Copernicus, Descartes, Isaac Newton, and a lot, and even those people who are today researching on this COVID vaccine, right? So if they think that what would happen, when will this vaccine really start working? We would have been lost. We would have been, totally lost. So the idea of research in pure mathematics is not immediately you get something. It is a long-term process. And in this process, you enrich yourself and you enrich others. You enrich the entire society. You enrich human beings. You help to save lives. I'm talking to you. You who are doing a research in pure mathematics, you save people's life. You built up technologies. You built up things in which I and maybe my family is living. So don't take a step back to think that what would happen, what is going to happen, what is the materialistic thing which I'm going to get. Pure mathematical research, if research is not done, we would not have been survived. If research is not there, we would not have talked. If research is not there, YouTube would not have been. If research is not there, I would have not been able to see without my specs. All these are the results of research. So that is how important is pure mathematics research. I know it is difficult, I know it is abstract, I know it is very frustrating at some times, but this is what it is. You create the steps in which the entire world survives. You create the steps in which we move forward. You create the steps to save human and other lives. So that's all. It has been a long, I understand, but I think that I have touched base more or less in the important part of how to build a career in mathematics. Before I close down this video, I would like to tell you that one thing you should do, that is you check the reality. Please do check the reality. I showed those points that how would you know that you're good in mathematics? Touch base on those points, select on those points, understand whether you are good at. Go ahead and do more researches on what I have talked, what are the emerging careers in mathematics, what are the universities, schools, colleges, institutions, what is providing what in this COVID times, how it is safe to go ahead, and what are the things that you need to do, right? So more or less, I have covered the essential aspects. The key factors, I would say, that you need to understand that at all are you good in mathematics, those checkpoints. What do you mean by career in mathematics? Overall, I have shown you a lot of a lot of details in pure and applied mathematics, what is meteorology, what is ergodic theory, and all those things. And lastly, don't ever take a step back in order to think that should I do a career in pure mathematics? Please go ahead. If your time, energy, finance, society, your surroundings, your family, they permit that yes, you can go ahead and do a research in pure mathematics, that is the best and the noblest profession to do. Because if you don't do, we don't survive. If you don't go ahead, there are problems. If you don't think, then humanity is stagnated at a certain point. Right. So that's all. I think you have liked, or maybe you can put up your comment in my video. If you have more questions related to a particular profession or a career, you can talk to me, because this is what I have been doing for quite a long. I've been educating, mentoring, and helping students to take a proper path. Do let me know your comments, and please hit on the like button and do subscribe, share, and let me know how do you like. I will be waiting for your comments. Bye, and have a great career in mathematics. All the best.